Hello and welcome to time series forecasting. In this video I'm going to talk about multicollinearity in particular. Essentially we are interested in predicting this yt variable based on a bunch of x variables. For example, we may want to estimate yt based on these 3x variables. We want all these x variables to explain variation in y variable. That is, we want our r squared value, which shows how much variation these three variables together show in the y variable, to be very high. That is, we want our r squared to be close to 1. But sometimes we deal with a data set where more than one variable or one of the variables explain a lot of variation in another explanatory variable. For example, in this case, we may have a variable x2t which may be explaining a lot of variation in x1t, and our r squared will be exactly equal to 1. So this type of a relationship is called a perfect linear relationship. For example, you may be regressing a data and you have time as explanatory variable in minutes and time in hours. So see here, both of these two variables, they are perfectly collinear in the sense that this variable is exactly 60 times this variable. So we say that both of these variables are perfectly collinear. But most of the time we get an r squared, and remember this r squared is between these explanatory variables, which is very close to 1 rather than exactly 1. This type of situation is called multicollinearity. Now, we don't want these x variables to be highly collinear with each other. If these variables are collinear with each other, then we get problem with the variance of these betas, and this will affect the prediction intervals that we'll get, and it will be very hard to make statistical inferences about the statistical significance of any of these variables. Thus, we don't want these variables to be highly collinear with each other, and this is one thing that we should be careful while selecting our predictors. That when we select our predictors, we should be careful that we do not select two predictors those are highly collinear with each other or highly correlated with each other. Essentially, the point here is to predict this variable y based on these predictors. And if one predictor is highly correlated with another predictor, it means both predictors contain the same information, and we should be probably dropping one of these because one is redundant. Okay, so this is the problem of multicollinearity. What we can do is, in R, we can detect multicollinearity by what we call variance inflation function. After our regression equation, we can use this function VIF and see what is the VIF for each of the variables. And normally a VIF greater than 10 means the variable is highly collinear with other variables, and we should probably drop that variable. So this is one thing that we can do. Now, this arbitrary value of 10 is probably not very useful in practice, but nevertheless it helps you to identify that some of the variables are highly correlated with each other, and you should go back and select the best predictors and drop the variables so that you can make suitable statistical inferences about your coefficient values. So this was the concept of multicollinearity, and you can check multicollinearity by this VIF function. Alright, I'll see you in the next video. Bye-bye.